Welcome everyone on our next session. I think you are here to learn something about how to run the stateful application in Kubernetes. And I'm happy to be here with Jakub Scholz. But before I hand it over to him, I want to remind you can ask questions in a Slido, or after the presentation, we will do also Q&A. So Jakub, enjoy.
Thanks for the introduction, and welcome to my talk about running stateful applications on Kubernetes. My name is Jakub Scholz, and I work at Red Hat as engineer, and I'm running stateful applications on Kubernetes since 2016. At that time, it was something like Kubernetes 1.3, and the brand new thing there was something called PetSets. Who remembers PetSets? That's the really old guys who will die soon. But the last 5 years, what I'm really focusing on is working on the project called Strimzi, which is a CNCF Cloud Native Computing Foundation sandbox project, which is about running Apache Kafka on Kubernetes. So obviously, that's where I will use a lot of the experience, but what I will be talking about should apply to other applications as well. And maybe for a start, we should try to define what I mean when I talk about stateful applications, because there are different views, different definitions. But what I'm talking about are applications which basically get some data and store them into some persistent store, persistent volumes into some disks. So typically, these would be things such as databases, like your Postgres or MySQL or MariaDB or whatever is in these days, but also this new kind of cloud-native generation of databases such as Mongo, Vitess, and so on. Obviously, there's also a lot of applications in the messaging and streaming space. That's where the Apache Kafka fits in, but there are also other Pulsar, NATS, ActiveMQ, and so on. Then storage is surprisingly also a stateful application which uses storage to store storage. So what you can imagine under this are, for example, different object storage applications such as Minio, which basically take a storage and then make it into object storage and then store your objects on the persistent volumes. Monitoring is another area which kind of fits into the pattern. To be honest, you can also fold this under databases, for example, because Prometheus, at the core, it's basically a database. And there are many others as well. So these will be the applications which I will be talking about and focusing on. Next thing we should probably talk about is why should we even consider running these applications on Kubernetes? That's an interesting question, because quite often when you speak about Kubernetes, a lot of people think about scalability and elasticity and so on. And let's be honest, a lot of the stateful applications, a lot of the databases, they are not always that scalable and that elastic. They don't always scale horizontally. If you have some of the traditional SQL databases and so on, then often it's kind of the main server with some high availability, but it doesn't have 100 different charts and so on always. So some of these applications can do the scaling and are elastic, but it's not always the case. And even where it is the case, there's this thing called data gravity. So they have the data which are stored on the disk, and just by spawning a new pod, it doesn't necessarily mean that you kind of scale the application, because you either need to shift the data or you need to collect the new data. So even Apache Kafka, which kind of is very well horizontally scalable and can be quite elastic, the time horizon is completely different than you would have, for example, for some stateless application. You would not kind of scale it down 1 minute and then 5 minutes later, scale it up 1 minute and then scale it down 5 minutes later. You would, for example, kind of do it with a more long-term view by onboarding new projects, rising customer base, and so on. So these things might apply, but it's not exactly the same as with stateless applications. Another thing which is often mentioned is bin packing. That basically means that you can kind of, Kubernetes help you to kind of pack the different applications densely into the worker nodes and better utilize the resources and so on. Again, a lot of the stateful applications would run rather in big large pods rather than hundreds of super small pods. So there are some benefits from the bin packing, but yeah, again, if you have big pods with 20 CPUs, 100 gigs of memory for some SQL database, then the bin packing is not your main issue which you need to have addressed. But then there are some other things which I think are super useful if these I covered before were not that convincing, and one of them is portability. If you look at Kubernetes, what it is, it's basically a platform, but it's also a great abstraction over the infrastructure. You can run Kubernetes everywhere. You can run it in a public cloud, you can run it in a private cloud, you can run it on a bare metal, you can run it on the edge. And when you write something to run on Kubernetes, you can run it on all these different places. And there's a lot of talk about the things such as how to avoid vendor lock-in and not to use some managed services from the public cloud because maybe you will want to move somewhere else next year. And I know that quite often it's something what never happens. But I think the value which Kubernetes give you is a bit higher there because it's not just about changing the provider, but it's also about running in different places. So, for example, you might do some development in public cloud, but for production where the government tells you, oh, you cannot use and store this data in some public cloud with Amazon because the evil US government and whatever, you have to keep it locally, then, well, you can deploy your production environment on bare metal locally, keep the production data there, but use the public cloud, for example, for the development, right? And thanks to Kubernetes, you can run the same things there in the same way. You do not need to kind of re-engineer the things. Another thing which is obviously great is the community and the ecosystem which Kubernetes give you. Like, we can see that in a lot of the talks here, we can see it in the people here on the conference, but imagine how much stuff you get for free for things like monitoring or observability, which is basically first-class integration with Kubernetes, and which makes it very easy to integrate. Or think about the things such as GitOps, which basically allow you very easily manage the stateful applications through the GitOps processes out of the box because these tools already exist there, even if maybe the first thought wasn't always stateful applications when they were developed. So that's a huge value as well. And then last but not least, and this is something I call it time to market. But what I'm trying to say with it is, if you already have Kubernetes in your company or in your project and use it for the stateless applications, you have your operations team kind of trained for it. They know how to use it. They know how to monitor it. And now if you need to run some database or some messaging system or some streaming platform, then why should these people learn something new and deploy it on some VMs or on some bare metal when you can reuse the same things which they already know and which they use every day, right? You can use the same kubectl, you can use the same YAMLs to manage the stateful applications as you already do for the stateless. You need less trainings for the people working with these tools. And that also means you can get faster to the market. So hopefully that has explained why should you at least consider running stateful applications on Kubernetes? And now let's talk a bit more about how to do it. Luckily enough, unless you just wrote your amazing brand new database yesterday and need to deploy it on Kubernetes, then most probably you do not need to start from zero because all of the kind of existing well-known tools, most likely somebody already tried it, somebody already deployed it, and you just need to reuse it. What you can start with on the beginning is basically just a bunch of YAML files which you have in some folder, and then you do kubectl apply, and it creates the resources, deploys your database, and hooray, you can go and start running. That's great if you want to just give something a try for 5 or 10 minutes, but if you take it seriously, you will very quickly find out that that's not enough. You will have different environments with different configurations. You will want to change the things quickly. So probably quite quickly, you will find out something called Helm Charts, which gives you all this templating and this kind of reconfiguration functionality, and makes the life easier for you because you can easily say, oh, this is my development environment. Let's use some kind of development settings. This is my production environment. Let's use the real beefy machines and so on. But The Helm charts, they kind of take care of the installation, but they don't really care that well of what's called the day two operations, of kind of running the application, reconfiguring it when you need to do some changes, doing upgrades, certificate renewals, and so on. So I want to kind of demonstrate what might go wrong on a Kafka example. Imagine you have a Kafka cluster with 4 nodes. And this is a Kafka example, but the pattern applies for many other stateful applications as well. In Kafka, one of these nodes will have this kind of controller role, which means that it has a bit more responsibility. It kind of delegates some tasks to the other brokers and so on. And now, if you would kind of just naively roll out a new configuration to the Kafka cluster by rolling the pods, for example, just by updating some stateful set, something like this can happen. Kubernetes come and roll the first pod. The controller role shifts to the second one. The first pod starts, great. Kubernetes move on and roll the second pod. The second pod was now the controller, so the controller role shifts again. And so on until the whole cluster is rolled, and the controller role is again at the end on the first pod, on the first broker. Now, with Kafka, this is not the end of the world, but changing the controller always causes disruptions to the Kafka cluster, and normally you want to avoid it. So if you would have a human operator who knows Kafka and knows how to use it, then the human operator would do something like this. Roll the second pod, roll the third pod, roll the fourth pod, and then, at the end, as a last thing, it will actually roll the first pod, which has the controller role, and then the controller role will shift to the second pod. So as a result, the controller role didn't kind of transition 4 times, but only once. And with Kafka, it's actually a lot more complicated, and this is just one of the parts of the rolling update. But I hope this kind of demonstrates that it's not just about the installation, but it's also about how you run these things. And that's where, obviously, operators come in. I hope you all heard about operators, because there were several other talks here, but also because it's not really a completely new concept. But the operators basically try to encode this knowledge which the human operator would have into a process which does these things for you. So what it means is that you do not need to understand in detail these different things because somebody did that for you and somebody wrote it into the code which does these things. So they kind of take it to the next level. Let me stop for a moment at the operators. If you want to run some common, well-known databases or applications, quite often there will be multiple operators. They will have different licenses, but they will have also different maturity and different features. So you should be careful which one you choose because, not everyone might be equal. Let's be honest, I'm a big fan of the operators, and I should be kind of rooting for them, and I should be telling you, use operators, and it is likely the case. But it's not really a magic. You still need to know things if you want to do that. And let me show you a simple example. So this is a simple YAML file, which you can use to deploy Apache Kafka cluster on Kubernetes. 20 lines of YAML gives you running, fully functioning Kafka cluster. That's the magic, right? Now, let me show you the secret. This is how the file would look like somewhere in production. Scrolling, 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 scrolling. Let's not do it till the end, but the reality is that if you want to make a production cluster with it, you will need to add things like security. You will need to add some special configuration to tune it for your use cases. You will need to add some configs to control how the pods will be scheduled by Kubernetes and so on. So you still need quite a lot of knowledge, and it's not really the magic as it looks like on the first look. And in general, and this might be a bit subjective in my personal view, but if you want to stick with the Helm charts, I think that's fine. They have some advantages. In general, they always give you more flexibility because you have much more space to configure it exactly as you want, and you have much more space to do it exactly as you want. But it also means you need to know a lot more because a lot of the tasks you will need to do them manually. And you also need to be much bigger expert on the application because you need to understand it much better. On the other hand, the operators, they will be always a bit more opinionated, and you won't have sometimes the choice to do it exactly as you want because the operators authors decided to do it differently. But it does a lot more things for you. So, for example, if you would want to configure security, you do not need to know the exact commands, how to kind of write it into the config file. You just write some kind of simplified YAML, which something like authentication type MTLS or something like that. So there's a lot of stuff which it does for you. And especially if you are not really an experienced operator for the application, the operators will do a lot of the stuff for you. So that was about how you can install it, how you can get started. And now let's talk about some of the pitfalls which I saw over the years happen quite often. And they apply to all of the ways how to install it. It doesn't matter whether it's operator or Helm chart. The way how you apply these might differ, but all of these are things you should be careful about. One of the things you probably care about with the stateful application is performance. And performance isn't necessarily about getting the highest number once in a blue moon with the wind in your back. It's more about the stability and predictability. If your applications need 10,000 transactions per second from their database, then that's what you need and that's what you want to get basically any time. You do not care that sometime you can get even 11,000. If other time when you need 10,000, you get only 1,000, right? So the predictability and stability is important. Now, one of the things which you should always do, which people often forgot about, is configuring the resources for the application. Configuring the CPU and memory resource requirements, that always helps to kind of reserve these resources, make sure they are available, and make sure kind of the application can rely on them. And it doesn't happen that it suddenly needs CPU and the CPU isn't there, right? So that's the number one thing, which unfortunately still doesn't seem to be completely automatic for many users. Another thing is to kind of think a bit about the noisy neighbors, kind of the applications which are using, for example, the same resources. It might be, for example, storage bandwidth might be one of the resources which you kind of often run out of. And often it's happened because kind of you have multiple colliding stateful applications which use a lot of these resources. So what you can do is you can try to identify these. And then when you identify these applications, you can use Kubernetes pod anti-affinity to kind of tell Kubernetes, please do not schedule these applications on the same worker nodes because, yeah, they might be the noisy neighbors. They might kind of bottleneck on the same resources. Let's instead schedule them each on a different node. And that way kind of help to avoid these issues a bit. Now, it's not always enough because even if you have their other applications, even if they are not stateful, they might still use network, they obviously still use CPU, they obviously still use memory. So sometimes it's not enough to just set the pod anti-affinity and you need to configure dedicated nodes. Because even with the pod anti-affinity, what will happen is that your stateful application will be still scheduled on the node with many other applications. And what you can do and what you can consider is you can use taints on the node. So you can taint the node, which basically means that only some applications which tolerate this taint can be scheduled on this node. And then you can set the toleration in your stateful application. And in addition, you can use affinity to basically get this application scheduled on this dedicated node. And then suddenly it looks something like this. The node is dedicated, and it's only the stateful application which gets scheduled there. So now it has all the resources. There's no noisy neighbors because there are basically no neighbors at all. Now, Some people think that to run stateful applications on Kubernetes, you always need dedicated nodes. That's definitely not the case. A lot depends on the size, right? Like if your database pod has anyway 10, 20 CPUs and 100 gigs of RAM, which happens quite often, like it or not, then it probably makes sense to use the dedicated node. If you use just a small database for some development or just new small project which kind of didn't completely took off yet, and it has just few CPUs and a little bit of RAM, then obviously dedicated nodes might not make sense for you because it would be kind of huge waste of resources. So it's more something to consider. Obviously, storage plays a big role in the performance as well, because it's for these stateful applications, it's one of the key components. So there are some things to be careful about the storage as well. Like you should carefully think about what the storage requirements of the stateful application are, because there are many different types. There is read-write-one storage, there's read-write-many storage, there's NFS storage or other file storage types, there's block storage, and so on. And now different applications need different things. So for example, Apache Kafka is completely fine with read-write-one storage and actually requires block storage. If you try to run it on NFS, it won't work and it will be terribly slow even when it works and so on. But there are other applications which actually want to use NFS because they use it for some kind of special log management and they use it for high availability and so on. So it's not kind of one answer which would fit all the applications. So you should very well consider what application you want to run, what's the requirements, and then check that you have the right storage for it. Another trap which I kind of often see is how the replication is done. Again, different stateful applications approach it differently. Apache Kafka, for example, has its own application-level replication. So when you send a message to one of the brokers, the common configuration is that the message is replicated to the other brokers as a kind of form of availability, reliability, and backup. So it doesn't really need the storage, which does some additional replication. But you will have also other applications which will not do some application-level replication and will want the replication to happen on the storage level. So again, this is something to check out and make sure you are using the right thing. And just to give you an idea why it's important, so for example, what I saw with Kafka is, imagine you have a Kafka cluster which is getting 100 megabytes of messages per second. Now, it's fairly big, but it's not that big for Kafka. Now, it's replicated to 2 other nodes usually. So that's another 200 megabytes per second of traffic in your cluster. Then each of these nodes sends it to some storage. If it's over network again, then, well, that might be in total another 300 megabytes per second. And if the storage is like this, replicated to 3 disks, then again, that's another 600 megabytes per second. So you started with fairly reasonable 100 megabytes per second, but suddenly this somewhere in your cluster, in your cloud creates 1200 megabytes per second of flow, right? So if you keep this under control, you can save a lot of resources and a lot of performance. For many applications, you can also use local storage. Again, you should check whether the database or messaging system you want to use fits that. But if it fits, then this might be an interesting option, especially, for example, on bare metal, because yeah, we all know that these super expensive storage appliances and so on are not always easy to get by. So local storage might be an interesting option. It has its downsides as well, but yeah, definitely something you can consider. What you can consider, but what you should be careful about, is cloud-native storage as well. From my experience, a lot of the cloud-native storage products or projects, it's not always easy to kind of fine-tune their performance. It's not always easy to kind of get it working properly. And if you get it, it's often very slow. The Portworx guys, I talked with them yesterday. They were insisting that their storage works great, so I'm going to trust them. But and in general, I'm not trying to say that all cloud-native storage is bad. I'm just saying if you use that, it's an interesting option, but check that it gives you the performance you want and that it really does the job for you. Another thing to talk about is availability and reliability. These things which we talk about here, databases, some messaging buses, and so on, they are like quite often the centerpiece of your architecture, of your application landscape. All the applications connect to it, all the applications communicate through it. So losing them or losing their data, that's usually a major problem. So we should talk about it a bit as well. And some things to take care of is distributing the pods, which is quite important because you do not want, for example, all your replicas of your database end up on the same worker host like this, because when the worker host dies, oh, it's that one, this one. If the worker host dies, then you lost all the replicas and you lost your whole application, right? It might recover, but even if it restarts on different nodes, you still lost some time, you still have some disruption. So what you want to use is, again, something like pod anti-affinity or topology spread constraints to kind of nicely distribute the pods across all the different nodes. But that is actually not enough because in many cases, your cluster is running in different availability zones. It's called availability zones in the public clouds, like if you used AWS, you know that. But usually you have similar concept even in your local data center, for example. You might have different fireproof rooms in your data center, or you might have just different racks in there. So usually this is something what shows up even in other situations than public cloud. And what happens there is you want to avoid situation, again, I'm using Kafka as a kind of tool to demonstrate this. You want to avoid a situation like this where maybe all the pods are running on different nodes, but most of them are in the same zone. Because if you lose that zone, then you again lost most of your replicas, most of your shards. And to make it even worse, if you have something that's really horizontally scalable like Kafka, this propagates to the application level as well. So in a cluster like this, it might even be that your topics and their replicas are located in the same zone as well. So if it's some Google data center which gets flooded, you might lose all your data as well. So what's really important to do is to use topology spread constraints to nicely spread the pods, the brokers, across the different zones. But often in Kafka, it's called rack awareness. It will be called differently, possibly in other applications. But you want to make sure that this kind of propagates to the application level and that your replicas of the data are spread evenly across the zones as well. Now, another thing I want to talk about was about controlling the disruption. Yesterday, here was a great talk about disruptions to pod exposed by services. And the disruptions, they are a problem for stateful applications as well. Some of them you can't control. If your data center burns out, well, maybe you should have better fire safety measures or something. But in general, sometimes it's just a bad luck. But a lot of the situations, it's voluntary disruptions which are actually caused by some action you or someone from your ops team took. And from that, you should make sure that pod disruption budgets are configured to kind of protect you from this. So imagine you have a Kubernetes cluster like this with 6 nodes, and it's mostly empty, and you want to scale down the worker nodes. So let's say some cluster autoscaler decides to scale the nodes 4, 5, and 6. So it cordons them, it deletes the application running on them, and then they are scheduled on the remaining nodes. Now, that's great, it works, you save some costs, but it moved all the pods at the same time. And again, your SQL database or Kafka cluster or whatever it was not available during that time. So you should configure a pod disruption budget to control this disruption. And still, the nodes will be cordoned, but the pods of your application will be moved one by one. And there are always enough replicas running, which can kind of take over the traffic. So that's it. For the next steps, I hope I got your interest and you will now try, if you are not running any stateful application, that you will try to run some. Just kind of some next steps. The Operator Hub and Artifact Hub are kind of catalogs for operators and for various Helm charts and so on. So if you want to try running your database or messaging system on Kubernetes, this might be a good first step to kind of find the right Helm chart or operator. And then I wanted to point out to this Data on Kubernetes community, which is part of the CNCF ecosystem as well. And that's a community which basically focus on running stateful applications as I define them here more or less on Kubernetes. So you find there a lot of meetups, a lot of talks, a lot of blog posts about this, but it has also a Slack where kind of all the people from the different projects around this are. So if you want to help with running some Postgres on Kubernetes, all the operator authors and so on are usually there. So that's a good tip as well. And that's it. And if you have any questions, then I think we should have still a few more minutes. And if not, I should be still around for a few more hours, so feel free to stop me. And if you want to talk in more detail about Kafka as well, then yeah, we can do that as well. Thanks.
Thank you. Thank you, Jakub. We have 3 questions in the slide. You can see it there, but I will read it also. So let's start with the first one, with one like. Is there any kind of limits, topics, hardware, project size when it's not worth running Kafka in Kubernetes cluster and it's better to move it to bare metal or VMs?
To be honest, I did not run into such limit. I think a lot of these limits are more artificial. A lot of the companies I, for example, worked with in the past, they have some kind of rules like let's not have Kubernetes clusters with more than so many worker nodes and so on. That also sets limits. But I don't think that in general, Kubernetes is kind of the limiting factor from this respect that you would kind of say this is too big for Kubernetes.
Thank you. Another one is it a great idea to have one dedicated node for big stateful app and a lot smaller other deployments that does not need access to storage?
I think it depends on how you define the big stateful app. I think the size really has to make sense. Like, if your stateful app pod is sized to have 4 CPUs and 16 gigs of memory, and your dedicated nodes would have 24 CPUs and 128 gigs of memory, the kind of fit isn't probably there, and it would be a huge waste of resources. If you all like with Kafka or Postgres and so on, it's not uncommon that you actually have the pod really big with 12 CPUs and more and 100 and more gigs of RAM. And in that case, I think the dedicated host is kind of a no-brainer because it just helps with the isolation and so on.
Mm-hmm. And the last but not least, could you elaborate how taint toleration and affinity work?
So a taint is basically something you set on the worker node. And it's like, when you set it, the node is basically tainted, and it works like imagine it as if the other applications kind of see it as tainted and don't want to schedule there, like that's, oh. And the tolerations are actually how you tell the application, hey, this taint is something you should feel fine with and you should tolerate it. But the taint and the toleration alone, they basically mean that the application which has the toleration for the taint can be scheduled to this node. But on itself, it doesn't mean that it will be scheduled on this node. So that's why you usually need to add a node affinity, which kind of in addition gives the pod kind of the Kubernetes scheduler kind of the instruction that this pod should be scheduled on this dedicated node. Because otherwise, what can happen, and it's not completely uncommon when someone barely configures it, that you create a dedicated node, you set up the taints and the tolerations, but in Kubernetes decide to schedule your stateful application to some completely different node, and you aren't surprised, oh, why it's not running there, right? That's why kind of the node affinity is important there as well, because that kind of makes sure that this application is scheduled to the dedicated node. The taints and tolerations that are more, it can be scheduled there, but it doesn't have to.
Thank you, Jakub. And do we have other questions that you can ask live? No? Okay. So thank you, Jakub. And now you can go to enjoy the coffee break, and we will meet at 11 a.m. here. Thank you.
Thanks, everyone.